Here's the practice assessment, chapter 3. We start off solving equations by graphing. If we use this right here, y equals mx plus b, which is our y-intercept, point y-intercept form, right? Then we know that this is our slope. This is our y-intercept. And if we use that for each one of these equations, we should be able to figure this out. Fletcher, what's my slope on this top equation? Can you read that? Yeah, what's my slope? Or what's my y-intercept? On that one right there. Look. No, I'm looking at the top equation. We use this. Point slope, 4. So that's my y-intercept. So we go on to the y-axis, which is right here, and we go up to 4. And that's where it crosses that y-axis. And then we go over, what's my slope, Reese? 2 over 1, right? 2 over 1. So my slope in this is going to be 2 over 1 with 1, which means it's rise over run. So we go up 2 and over 1, and that would be our line coming through right there. Okay? Up 2 over 1, because that's our slope. Right here. Yeah, you got to go from 4. You got to go from that point, go up 2, and then over 1. All right? Preston, what's my y-intercept on the bottom equation? -3. So on y, I'm going to go down to -3, and I'm going to put my dot. All right? What is my slope, Paris? The bottom equation. This equation here. -5 or -5 over 1, right? So from here, I'm going to go down 5, from this point, 1, 2, 3, 4, 5, and I'm going to go over 1. So I've got my line coming through like that. Okay? This solves the equation. Where do these lines cross? At x equals -2 and y equals 2, right? That's our solution for that. For how we graph it. See how we do that? Good with this? You weren't paying attention. You weren't paying attention. You weren't paying attention. Because I said we were going to do the whole thing, I'm going to have it on recording. So yes, we did this yesterday, but we're doing it again. Okay. Got her, Otter. All right. All right. Solve the equations by substitution. Substitution means you're going to replace an x or a y with the other equation, Preston. So I look at this and I say, what can I do to easily make something that I can replace it with? So we take this bottom equation, right? Take that bottom equation, and we're going to solve for y on that bottom equation. So we would have y, if we bring this over, would equal -1 minus 2x. Okay? See how we got that, though? Okay. See why we got it? Because it's easy. Now we're going to take this y, and we're going to plop it back into this other equation. So we're going to have 6x minus 3 times -1 minus 2x equals a -33. Why did I put that -1 minus 2x in here, Preston? That's y, right? We replaced that y. Katie, do you see that? Okay. So now I'm going to solve for this. 6x minus -3 times a -1 is a +3. -3 times a -2 is a +6. X equals minus 33. Combine these, it's 12x plus 3 equals minus 33. 12x equals 36. Negative 36. And x equals negative 3. All right, are we done? We have to figure our y. So let's take this. We could take this here. We can plop it right back into that equation up there, right? So we put it in there. Y equals negative 1 minus 2 times negative 3. Negative 1 minus plus 6 equals 5. Y equals 5. We've got our two answers. All right. Let's take a look at the next one. Through elimination. Now we're going to add or subtract the two equations to try and eliminate one of the variables, right? And this is kind of easy because we have 4's for x's. So we can subtract these and come up with, and we can eliminate the 4's, right? So 4x minus 4x is 0. Minus 3y minus a plus y, 5y, is a minus 8y. Minus 2 minus 14 is minus 16. Divide both sides by negative 8. Y equals 2. Now we're going to plug that back into one of these. Let's put it back into that one right there. So it's 4x minus 3 times 2 equals negative 2. 4x minus 6 equals negative 2. 4x equals 4. No, actually a minus 8, right? Nope, plus 4. I'm all goofed up here. I'm seeing a minus 6 there. So we bring that over. That's going to be a plus 4. X equals 1. Did I do it right? All right, good. Okay. Take a look at the next one down. Now we're going to graph inequalities. I'm going to caution you here. I have a less than or equal to here and a greater than or equal to. That means they're going to be solid lines. If we had just a greater than or just a less than, it's going to be a dashed line. Very important to recognize that. Hint, hint. Hint, hint. All right. So let's graph this. Again, we can use this right here. Y equals mx plus b, right? We know that our 3 here is going to be our y-intercept, so we go up to 3. Our slope is going to be 1 over 1. So it's going to be right here, so it's going to be something like that. All right? Now, we're going to do the 0, 0 test on this one. So we're going to put 0, 0 in for this equation. 0 is less than or equal to 0 plus 3. Is 0 less than 3? True. So here's our origin. We know that we shade in this area, right? That looks pretty bad. I can't. One of these perfectionists. If Nikki was here, then I wouldn't be so bad. What can we say to Nikki while she's listening to this? Sure she will. So we shade off this side here. All right? Dumb and Dumber. All right. So let's take a look at this one. We've got our y-intercept at 2. We also go up 1 over 1 for the slope, and we come down here. But this time, we do our 0, 0 test, origin, right? 0 is greater than or equal to 0 plus 2. Is that true or false? False. So we have to go to the opposite side over here. So what is right in the middle? This little bit right in here is are solutions to those two equations. These numbers that fall in between there, those are the solutions to those two inequalities. Those where the numbers would fall in, that they would be solutions. All right? That's what that says. Good? Cool beans. All right, let's get into the second half of this page. This is going to be new, somewhat new. This is graphing again. Yes, Preston? Okay. It's just graphing again, but here's the difference. Here's the difference. We're going to come up with vertexes. Vertexes are where a shape starts making edges like this. This would be a vertex, this would be a vertex, this would be a vertex, where it changes directions, okay? And we need to find these vertexes when we graph this, because those vertexes, then we're going to put in the x value and the y value for these coordinate points, all right? And that's going to tell us whether, how big this number is, and it's going to give us our minimum number and our maximum number, the biggest and the smallest. All right? That's what we're going to do. So the first thing we have to do is we have to graph this. We're going to take a look. Remember, use the y equals mx plus b. All right? We know it crosses at 3. It's got a slope of a -1 or a -1 over 1. So I'm going to go down 1 and over 1. So my line is going to look something like that for that one. Now, it is, notice these are all less than or equal to, so they're all solid lines. On these, that's all you're going to find. You're never going to have where it's just less than or just greater than, because then those vertex points wouldn't be actually solutions. All right, so I do my 0, 0 test. Where is it? 0 was less than 0 plus 3. Yeah, that's true. So I'm gonna shade off this way here. All right, let's take a look at my next one. Do that one in blue. I've got my y-intercept at 2. I've got my slope at a -1 over 2. So my line actually looks something in here. Close enough. Do my 0, 0. Yeah, I'm a little bit off. Do my 0, 0 here. 0 is less than or equal to 0 plus 2. Yeah, true. So my slope, where I'm shading in, is going to be right there. Yes? Yep, down 1 over 2. 1/2, or we could go up 1 and back 2. Either way. Depends on which one you want to put the negative on. All right. Let's do the last two in green. So x is greater than 0. That means that it's on the y-axis. And y is greater than 0. That means it's on the x-axis. So what do we have that will shade all together? Well, it's going to be this area right in here. Just that little area right in there. So we know our coordinate points are going to be, we've got 0, 2. Well, we know that that's one of our points where it crossed it right there. We know we've got 0, 0. That's the origin sitting in there because that's one of them. Then we have to come out here. This looks to be about like 3. So I'm going to say it's 3, 0. And this one up here, I'm going to guess a little bit. It's going to go up. It's going to be less than 2. It's going to be, let's say let's see, that should be up a little bit. Let's say 1. I'm going to just put something in there for x at 1, and I'm going to say y is going to be about 1.75. It can't be 2, because if it's 2, then it means this would be a parallel line, because this is 0, 2. So it's less than it a little bit. All right. Now I'm going to plug these numbers in to my p-value. So I'm going to take a look at the first one. If I plug these numbers in, 0 and 2, this would equal 6. All right? 0, 0 would equal 0. 3 would be negative 4 times 3 would be a negative 12. And then this one here would be negative 4 plus 5 point something, right? It'd be right around negative. It'd be right around 1. I'm going to say approximately 1. All right. It's not the lowest. It's not the highest. So we really don't have to worry about it. It's approximate. And what it is we're plugging this in. P equals negative 4 times 1 plus 3 times 1.75. 3 times 2 is 6, right? So it's something less than that. It might be 2 something. I mean, it doesn't matter because it's not going to fall as the lowest, which we know this one is the lowest, and we know this one is the highest. So we would have that our maximum point right here for the max is going to be 0, 2, and our minimum point is going to be 3, 0. All right? That would be your answers then for that one there. Looks like a mess, doesn't it? It is a mess, but that's how we do it. Yeah, that's how we do it. That's how we solve that to be able to determine what our min and max is. So it's a lot of work, but it's doable. It's going to be just like this with different numbers. Just like this with different numbers. All right. Let's go down to the next one. Solve the system equations through elimination. Here's how we do this. We're going to take two of these equations, whichever ones, and we're going to eliminate one of the variables. All right? What's nice is, in this one here, I got a negative z, and I got a plus z. So if I just add these two right here, I can come up with one of the equations because it's going to eliminate my z's, right? So let's add these two. So it'd be 5x plus y, then that z would be a 0, equals 19. All right? That's one of my equations. Let's take this equation and this equation and add those together. X plus y plus z equals 3, and 3x plus 2y minus z equals 13. Let's add those together now. X plus 3x is 4x, y plus 2y is 3y, z minus z is 0 equals 16. Now I want you to notice what I did here. I got it down to where I have two equations, two unknowns. That's what I did. I used these two, and I used this because I got this negative z here, and I got plus z's on the other two equations. That's why I used this equation with this one, and this equation with this one to come up with my two. Well, it just, to me, I'm looking at it making it easier. Could I use these two equations? Sure, and I would have subtracted them. Then get it down to two equations, two unknowns. Now we can take these two equations, 5x plus y equals 19, and 4x plus 3y equals 16. Now we're going to get rid of one of the other variables. What would I do to this? I'd probably multiply this one right here by 3, right? 15x. Why would I do that? Because I'd have a 3y here, and I'm going to make this a 3y. Plus 3y equals 57. This would be 4x plus 3y equals 16. Let's subtract them now. 11x, this would go to 0, and this would be 41. All right. Oh, this is a tough one. X equals 41 over 11. That would be tough, huh? Did I do any adding, subtracting wrong in there? Add that. Oh, that would be right. .72. I won't have one that's going to come up with fractions like this. But here's the next thing you do. You take this and put it back into one of these equations. And then either one of the ones with two unknowns. Solve it for y then. So you'd come up with a y equals something. Then you'd take your x and your y and you'd plug it back into one of these equations to find your z. See what I'm doing? So I broke it down to what x equals, found that, I went back, found out what y equals, and then I went back and found out what z equals. Now maybe on the assessment tomorrow, maybe you get rid of your x first, right? And then you solve for your y or z. And then you work your way back to find your other variables. All right? But that's what you're going to do. You're going to get it down to where you find one variable and then work your way back to find the other two. Okay? See that, Fletch? Cool beans. All right, let's take a look at the last one, matrix. Matrix. Matrix is it's actually kind of close to what we do right here. It's kind of close. Right? If we were going to put this in a matrix, this would be 4, 3, line 6, and then -1, -y, -1. Everybody see where I got these? These are the coefficients out in front of these variables, and then these are the numbers after the equal sign. All right? Now I'm going to start, I want to get it down to where this one here is 0 and this one here is 0. Okay? I want to get it to that point. I'm going to have to rewrite these. I don't want the red lines on there. All right. Good enough. So this was 3 and this was -1. All right. What do I want to do to this first? Katie, what do you think I want to do to this first? What's that? Times it by 4? Times the bottom one by 4? Right. Let's multiply this bottom one by 4. So this would come out to 4, 3, 6, -4, -4, -4. All right? See how I got that? Reese? Good. Now I'm going to add these two because I'm going to make this one 0. So I'm going to add these two and I'm going to put my results down in the bottom. So I'll write off my top line again, 4, 3, 6, and then I'm going to add the results. So 4 minus 4 is 0. 3 minus 4 is -1. 6 minus 4 is 2. Can I get rid of this -1 here? I just multiply through by a -1. 4, 3, 6, 0, 1, 2. We've got one of our ones down here now. Pretty nice, isn't it? That's what we want to get to. Now what do we do? Reese, what do I want to do? We want to make this one 0. Times by -3? Okay, so we would have on top here, we'd have 4, 3, 6, 0, -3, -6. Actually, this is supposed to be a -2 right here. So this would be +6. See how easy it is to goof that up? Real easy. All right. So let's add those together. 4, 0. We're going to put the results on top. And then this is 12. And on the bottom, let's just put back what we had here. We can do it like we divided through by 3 already. So we'll just put that back 1 or 0, 1, -2. Now we can divide the top one by 4. And we'd end up with 1, 0, 3, 0, 1, -2. Okay, now we have it. We know that our x equals 3 and our y equals -2. And that would be your answer. Does that help? Yes. All right.